Okay, so every time, listen up, every time we graph data, we have a relationship. We have two pieces of information, right? When we graph it, we have an X and we have a Y, correct? We have to identify one of these is referred to as the independent variable, and the independent variable will always be put on your x-axis. This will always be the independent variable, and I'm going to talk about how you know that. And the dependent variable is always going to be graphed on your y-axis, okay? So think of it as dependent. One of the variables depends on the other variable, okay? So the independent variable is the variable that you know. It's known. So let me give you an example. So in the previous example, we were looking at a relationship between text messages and monthly savings, the amount we save, right? Savings. Which variable, which one of these would you know the answer to right away? Would you know how many text messages you send in a month, or would you automatically know your savings? You know your text messages. Okay, think about it. The savings depends on how many text messages you're sending, remember? How much I save depends on the number of messages, right? Does that make sense? What about if I have a business and in my business I want to sell t-shirts? Okay, so I have the number of t-shirts I'm selling, and then of course if I'm selling something, what do I get? Money. I have my earnings. Well, do you think that the money I make depends on the number of t-shirts I sell, or the number of t-shirts depends on the money? The money I make depends on how many t-shirts I sell. So I know I can calculate how much, I can figure out how many t-shirts have I sold, and then that will give me how much money I've earned, okay? So the dependent variable is the variable that is affected when the independent variable is changed. Think about it. If I sell more t-shirts, so if I change the number of t-shirts, what happens to my earnings? If I sell more t-shirts, what happens? I earn more. Okay? So we have to figure out which variable is independent and which one is dependent. We're going to do a ton of examples and it will make more sense to you. So let's look at the first example, A. Can somebody read question A? So she's looking at recording her time. She's training for a race, so she's running. How long it takes her to run over time, over weeks. How many weeks? Maybe the first week she has a certain amount of time it took her to run. Let's say she's running 5 kilometers. Then the next week she runs again and she records her time. Then the next week she runs again and she records her time. Think about this. As you train more, as the weeks pass, what do you think's happening to her time? She's training. Okay, weeks would be independent. This is the variable I know. I'm going to put in 1 week, and then I'm going to figure out the time. I'm going to put in 2 weeks, and then I'm going to figure out the time. The time that it takes me to run depends on what week I'm at. If we compare the data, week 1 is probably going to be a really bad time compared to, let's say, week 10. Okay? So you're right. Weeks is independent, and the time of running is dependent. Let's try the next one. We're looking at a relationship between people's age and their shoe size. What would be the relationship between your age and your shoe size? What happens as you get older? We're actually gonna do this as a class. The relationship between your arm span, that means if you put your arms out like this, you're gonna measure from one fingertip to the other, and your height. There's actually a relationship between those two. Which one is independent and which one is dependent? Think about this. Does your shoe size depend on your age? Yes or no? Yes. So shoe size is dependent. And which axis do we always put dependent variable? X or Y? Y. Y is always dependent. That's why I went over this. Your shoe size would go here, and then your age is independent. I want you guys copying this down. Independent is always X. So if I'm comparing, if I'm comparing my age, so maybe when I'm 1 year old, all the way up to when I am 10, let's say, what do you think the pattern would be? What would the trend be? Would I start with a really big shoe size over here and then get smaller, or what would happen? What happens as your age increases? Your shoes get bigger. As you get older, your foot grows, yes? So your graph's gonna look something like this. And then all of a sudden, maybe it's gonna stop. I haven't had a different shoe size since I was in grade 9. I've had the same shoe size since grade 9. So maybe once you get to like 16 years old, your shoe size, I'm a size 8. It's gonna stay the same for all of the rest of my life. Okay?